Welcome. In this session in natural deduction, we'll explore a question which is, do universal quantifiers commute? We won't show this in general. We'll show it in one specific case. Let's suppose that what we want to explore is whether if for all x and for all y, a relation holds between x and y, we can conclude that for all y and for all x, that relation still holds. To do this, we'll set up a proof. We always begin our proofs by writing our premise, which is for all x, for all y, and this is the relation holds between x and y, and so that's our premise. And we then write our conclusion, which is for all y, for all x, that relation between x and y obtains. We then take a look at our premise and take a look at our conclusion and say, do I use forward or backward reasoning here? If I tried to use forward reasoning, I could substitute anything whatsoever, provided it didn't become bound in the process. I could substitute anything in this case except for the variable y in for x. Now, I could do that, but it's not clear to me that that would lead anywhere, because the rule to get to a for all y is a specific one, and that is I would have to use universal introduction. Well, that's backward reasoning. So my attempt at forward reasoning pointed me directly and saying, let's try backward reasoning instead. So I'll do that. I'll open up my assumption box, and I'll write the reason for the assumption box, which is that this is universal introduction. Now, a little technical note. We always write it as for all x, even though what we're introducing is y. Don't worry about that. This is the name of the rule. It's not a description of what's happening inside the formula. So this is a box, and I know it has to start at line 2, so I can fill in most of the justification for that line. And here, I now have to pick a variable. I'm going to pick a fresh variable, which is one that doesn't appear anywhere preceding. And in this case, I'll pick the letter z, because I'm going to try to introduce y, so I'll do that. So that's my assumption, and in this case we don't write anything here. Then I take this variable and I substitute it into the formula that's quantified. So the formula that's quantified is for all x. It's not just this little piece here, it's everything that follows that quantifier. So I then copy this into the bottom line, which is for all x, and now here, everywhere that y occurs, I substitute my fresh variable. So that'll be r of x and that fresh variable. My reasoning hasn't changed. Going forward wasn't fruitful before. It's probably not going to be fruitful now. So let's try backward reasoning again. So that would be a new assumption box. Am I allowed to do that? Yep. Yeah, I'm allowed to, because we frequently in propositional logic found ourselves nesting assumption boxes. So I open my box, I write down the reason, which is for all x introduction. It will be starting at line 3, and I don't know how far it'll go. And now I need yet another one. So could I put z in here again? That wouldn't be a very good choice. Let's make it a w instead. So w, and then I substitute w into this because it's free for x, and so that would be the relation now holds between a fresh variable w and a fresh variable z. I now take a look and say, what can I do? Well, what I want to do is I want to conclude this, and it looks like it's somehow buried inside these quantifiers. So the only thing left now is I now have to do some forward reasoning. And the forward reasoning I need to do is I need to get rid of this quantifier. So that means that this line 4 is going to have to be a universal elimination based on line 1. And when I do that, it'll get rid of this x, and I'll have to substitute something in place of x. So I'll write down what I'm going to be left with, and then I'll figure out how to fill that in. So what I'm left with for sure is for all y, r, and then I'm not sure what I'm going to put in for that, but I know for sure that y appears. So now I have a choice. Either I fill it in with z, or I fill it in with w. I look at my goal formula and I say, boy, it would be useful if I had a w there. So I'm going to put w in. I then take a look at this line, which is the most recently introduced, and my goal formula, and say, how could I get from here to here? And the answer is, well, that is an application of universal elimination. So that would be universal elimination based on line 4, and what I would be doing is I would be replacing y with the fresh variable z. Is that allowed? Certainly. So that would be line 5 of my proof. I've now completed this inner box. I can say that this statement, this formula, this line is justified by a box that began at 3 and ends at 5. I can now say that is a justified line in my formula. I've now completed this outer box. It's a box that started at 2 and now ends at 6. I now have a formula that's justified, and it gets a line number. And now I've completed my proof that in this particular instance, the universal quantifiers that I have commute. I can probably apply this line of reasoning to any sort of formula, provided I keep these side conditions, this term is free for x in the formula. I have to keep that in mind whenever I'm doing these.